GERO 200, how are you? It is Sunday, January 29th, 2023. First day of the Billabong Pipeline Pro, and it was all blown out and crappy. So there you go. Welcome to all the new students. And yes, a lot of you guys are veterans. You've been in the class for 3 weeks now. And Friday was the last day to add classes. And guess what? We had a bunch of people add. So I'm going to rehearse a little bit what those people need to do in terms of catching up, because it was their choice to wait this long, so they got to do catching up. We can't catch up for them. All right, so the first thing you guys got to do, I'm going to be sending this video. Okay, do understand that we communicate like no other group of professors. Jill and I are running this course along with Tara Mastro. Okay, yes, we are a husband and wife team. We have a crack team of people that are from our program. Just added Jillian Miller, who got her master's degree in gerontology, and they help us in terms of delivering the course. All right, so what you see here is a bunch of announcements. Okay, so if you just added the course chronologically, this is where it all started. All right, so you'll go back and you read through these announcements. What you see right here is boom. Okay, 2 different lectures. Okay, this is the first lecture, but more importantly, right here, this is how to get an A in Gerontology 200. It's a walkthrough, okay? It is a YouTube version of a kind of a syllabus, okay? And it explains everything. Also, download the syllabus. And within the syllabus, you'll see this really nicely laid out spreadsheet that explains how everything is going to be coming at you over the next couple of weeks, okay? So here we are, week 4, January 30th is tomorrow. So what happens is every Sunday night I post a lecture video just like this, and it guides you through how to navigate the course. Every week we have a weekly assignment you'll see you go into. Now, when you look at these YouTube lectures, okay, there is a channel that is devoted to this class right here. So it's GERO 200 Spring 2023. There's the first lecture, the second lecture, the third, boom, boom, because that's the how to get an A lecture, but it's essentially the first. And then this one's going to be going in right down here, all right? And so that's how it rolls as well, guys. So you guys are really set up to catch up. If you have any questions, okay, how to, you go in here and it tells you what you need to do if you just added the class. So you click on the how to folder, all right? It's gonna get into lots of different things, again, how to get an A, there it is again, okay, same lecture, how to use Turnitin, how to avoid plagiarism, how to post in discussion boards, these are all parts of the class. I'm actually over the Rona for the most part. And for those of you who don't know what that code is, I got COVID last week from some student at USC, all right? But I was highly vaccinated and I was positive for 4 days and then I was negative, okay? I also took Paxlovid, which is a monkey wrench. She's thrown in the machinery of the viruses, okay? All right, anyways, this goes through everything right here, okay? What to do in an emergency, and also what we see here, what to do if you just added GERO 200, it tells you right here. All right? All right, so we're all caught up. All right, I will be sending out a how-to video in terms of this first paper you're gonna write. There's graphs and figures with about 2 to 3 pages of text. You're gonna love it, you're gonna gather your own data, super fun, okay? Everything in this class is super fun, so I'm just letting you know that, okay? And you guys have been killing it on the discussion board, which really, really makes my heart go boosh like a cartoon, all right? Very cool. Okay, so weekly assignments, we're gonna go right in here, okay? This is how it rolls every week, guys. So this is what you do if you just added the class, okay? You come in here, we've done week 1, 2, and 3, so you gotta catch up on that way. Communicate with who? How am I gonna get this done? I go back to my announcement page. You communicate with her, all right? The course administrator and also co-instructor that does a bunch of lectures, okay? So contact Julia. Her email address is in the syllabus, okay? So, and she's gonna guide you in terms of what you need to do to catch up. Back to my weekly assignments, all right? Ready, so we've done 1, 2, and 3, okay? I'm going into 4. If you look at, for example, last week, 3, that's where my lecture goes. My lecture like this is gonna go in week 4. We posted it in there. I also sent it out via email, which is awesome, okay? Alrighty, then you have a whole list of curriculum that we want you to read, think about, okay? And then at the same time, what you usually do is you'll open up your quiz. So you will have two browsers or the same browser with two different tabs that are open. And that way you can go back and forth between the quiz and your readings, okay? This is the discussion board, okay? It gives you some perspective on what we're talking about. So we were talking about generations in this particular week, and the impact that the size and the wealth and the greediness and everything else of different generations has on your ability to buy a house, okay? So that's what this was all about right here, and just housing in general, all right? So that was last week, okay? So a couple different ways to go back here. I can go here, click, or I can also click right here in Blackboard. Blackboard kind of sucks, all right? And that's just a soapbox I can get on that USC charges you $8,500 a course, and yet we use a learning management system that is arcane, dinosaur-like, okay? Oh well. Maybe it's time to start protests in front of Bovard, okay? And question IT. All right, so we're going to go right in here. Theories of aging. So we've done a lot of background, all right? It's easy to go this way as well. Sometimes Blackboard lets you go backward in your browsers, other times it don't. We've gone through why it's so damn important to understand aging in terms of global economics. We've hedged our bets a lot about the financial impact globally and nationally that chronic non-communicable diseases of aging, like diabetes, heart disease, cancer, Alzheimer's disease, have on you as an individual, on the community, on the state, municipalities, federal government, and globally in terms of the burden, all right? And so it's your time, but it's your money, okay? And we have a huge financial burden in our country and any country that has a lot of old people of how to care for it, okay? We have Social Security, we have Medicare, we have housing issues. All these things are all bundled together, right? So we've talked about that. So what's going on in aging? Can we thwart aging? This is big business. A lot of you guys are business majors. So maybe we can add vitality in the years of being totally on the ball, extend that so that we're not, occupying doctors' offices and hospitals and being such a financial burden in the process, right? So we're going to learn about the biology behind aging and what can possibly be done to minimize this huge risk for disease that is aging, okay? So your threshold for disease just goes, this is young, here's disease, you got all kinds of play room, but when you get older, your margin of error is tiny, all right? So maybe we can increase that margin of error. That's a big concept in aging right now, okay? Aging research that is relevant to biology, all right? So this video is really cool to look at. It goes over 4 different concepts, all right? There's more. When you look at science, you become kind of a niche specialist. It's true of all forms of business, everything. You specialize in by looking at the world in one way, and then somebody else is looking at the world from their own perspective. There's actually a high degree of overlap, but it's like pieces of the puzzle and you begin to put them together, okay? That's kind of where we're at, scientifically with so much of how our bodies run, and especially when it comes to understanding aging. So they go over these different processes, okay? They look at, so our ability to replace old cells, okay? So, every time, and you guys have even seen it, okay? You slough off skin cells and lo and behold, you just don't have an open wound, okay? You have another skin cell that pushes right up behind it, okay? We produce, okay, mind-blowingly about 500 billion new immune system cells and push them out into our bloodstream every single day. So our bone marrow has this capacity, stem cells, to go through cell division, okay? But there's a limit, all right? We have trillions of red blood cells that are constantly turning over inside our blood as well. Again, where are they made? They're made by stem cells in the bone marrow, okay? When you get to my age, okay, your bone marrow has about 30% of the capacity for cell division. that your guys' bone marrow has, okay? So I'm kind of running out. So it slows down. I can't produce as many cells. You get the drill. You can see it in your parent's skin. Um, think about that all throughout the body. Skin is most visible because it's on the outside. That's why I bring that up, okay? So they talk about that right here, okay? They talk about how cells that are in this process of going through cell division and being pushed out into the body to perform jobs. There are middlemans in cell division, and they lose their capacity. And we normally have this little time bomb that will explode the cell. It basically implodes. The immune system goes, clears it. It's just like a wound, but it's aging. Okay. Anytime you've cut yourself, okay, your immune system is a big part of immune system that people don't even realize. It's just wound repair. Okay. Anytime you have a wound, you have to, you say you tear a ligament running, whatever. Somebody's got to go in there, get rid of the old torn cells, produce growth factors for new cells, and then they go away. Okay. Alrighty. So our old cells are doing this all the time, and the immune system gets rid of them. But there's a class of old cells that don't go away, and they just take up room. They secrete things that make the rest of the cells around them going, "What's going on?" and get kind of sickly. So there's a whole industry of, hey, what can we do to get rid of these guys? Okay. The cell division concept, there's an industry behind that. Okay. Then there's this nutrition and kind of the rate at which we live, and so it's really fad driven right now that maybe we should limit our nutrition. We should go on some fasts. And the whole concept is the cell then, when it doesn't have unlimited goodies around for making new cells all the time, it goes in and repairs everything that it has. Okay. And I'll talk to you about that, the companies that have got into that, okay? And then lastly, they go into stem cells, and there's all kinds of stem cell research. If cells, as shown in these first parts when you watch this video, lose their capacity for cell division, if we could just introduce brand new stem cells from donors, wouldn't that be beautiful, all right? And again, there's companies that's behind that, freezing your umbilical cord, or even better, if we could, just like we have blood types where we have tissue matches, if we could have universal donors, okay, where we get rid of the potential for tissue rejection and interaction, it would be awesome. All right, so that's what this video is all about. It gives you great background, and then there's reading that supports it. Now, what I would do, I would watch the video, I do the reading, and if I was somebody that was new to the class, okay, then I would just open up a separate browser, and I'm going to go into Blackboard. I have a lot more courses than you do, so it's going to show up, it's going to light up here. But I'm just going to go in right here. All right, so we're in. I'm going into my weekly assignments. I'm going down to week 4, okay? So now I'm going to have it open twice, and then what I would do is I would scroll down here. I'm going to go over that stuff in a sec, but I would open my reading quiz. And you guys are welcome to do this together. It doesn't matter. The only issue is you're going to all get pretty much different questions because we have pools of about 40 questions, okay? Look at Blackboard. It's all out of alignment, okay? It's limping to the finish line. But anyways, so you would choose the appropriate answer based on your reading and watching the videos and everything we talk about. And then you save the answer and you go to the next and to the next. I would read these guys over a little bit, all right, so that I can, when I'm doing the reading, understand what's going on, okay? All righty. They talked about oxidative environment. It talks about antagonistic pleiotropy right here, okay? What's good for you now is shitty for you later. That's what that means, okay? It says right here, when we think about optimal longevity, how does it differ from normal aging today, okay? And you go through this, okay? Less age-related disease sounds good to me. That's pretty logical, okay? Which is not a hallmark of aging, okay? Do I lose stem cells? Do my telomeres in the end shorten, okay? Cells don't die when they are supposed to. DNA repair, okay? Which one? Well, DNA repair is the answer. Yeah, aging has reduced DNA repair, not good or no DNA repair or something like that, okay? All right, this is true of stem cells as aging, okay, or what you're going to choose on there. All right, so that's what you're going to do there. So how do you know how to answer those questions, okay? So you watch the video. We're given some summary figures right here that I just put in there to go over the readings and the video. And you go and you open up the reading, and up it comes. It's a PDF file, so there you go. Alrighty, so click the arrow right here so that way you can scroll down and you just kind of go through the article. This was done a few years back again, and so I'm just going to guide you. What is aging theory? So again, Dr. Walsh's lab might look at it from one way. Dr. Richard's lab might look at it from another way. Dr. Master's lab might look at it from another way. You have all these perspectives. Okay, so there's going to be overlap at times. Okay. But then we all come together and we try to bring together kind of a unifying concept or unifying theory of what's going on with aging and then why is it happening? And then once we know, then maybe we can do some cool interventions to at least slow it down, right? Or be at the end of what they call successful agers, all right? So how do we age? That's a big question right there. How do we age, all right? Okay, and then can I modify the course of aging? Okay, so the one thing that has been shown in animal studies, and it's logical. Okay, it's like comparing a trained athlete, okay, to somebody who has had excessive overnutrition, is morbidly obese. Okay, so guess what? The trained athlete is going to live longer. Okay, the trained athlete is going to have less diseases like diabetes and heart disease and cancer. Well, that's what's been shown here. So what they do in mice, they give one group of mice unlimited food, and they just go, 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 and eat, and they get big. They get obese, become obese mice. Okay. The other ones, we kind of restrict how much food they're taking in. All right. So this is like this intermittent fasting concept. Okay. So about 30 to 40% fewer calories, and guess what? Less disease, and these animals live longer. Boom. Okay, so then we can go in and ask ourselves what is going on. Okay, and we see there's like a hormonal base. Okay, so there's this one hormone, it's a big one. Okay, it's called insulin-like growth factor, and we see the second hormone, insulin. Okay, when we have too much of these two hormones, okay, there's so much growth and cell division, it's excessive, and all of the cell's energy, all of your life energy is put into making new cells and not going in and saying, wait a minute, there's some damage in that cell. I better repair it. There's some DNA damage. There might be a mutation that might give me cancer or a mutation that makes my cells sickly and not work right. All right. So if you slow down your nutritional intake, do fasting, okay, then you have less insulin, IGF-1, and you have better repair. So that's the whole concept with that. Okay. All righty. Very cool. Alrighty, so is aging, is this program we have? Um, it's people used to think that like it was Darwinian, okay, but it just appears that the way it's set up is just a number of accumulated damages. Okay, one thing that happens is you guys have heard of oxidation, right? You all eat your blueberries, drink your acai berry juice, eat your vitamin E tabs. You're trying to reduce your level of oxidation because oxidation causes proteins to bind together in what's called cross-linking. And then they don't work so well. And we see more and more cross-linked proteins as we get older. And one of the worst case scenarios of cross-linking, okay, is when we look at diabetics and their blood glucose is so high that they get this kind of brownish candy coating of every single protein in the blood, and then it permeates into the tissue, and then that causes the immune system look at it like it would a bacteria or a virus. It looks all foreign and it flips out. Okay, so you have this chronic inflammation. So it's kind of a catchy terms, but they've called them advanced. Okay, meaning it's progressed pretty far along. Glycosylation or glycation, meaning we've stuck candy to it, glucose. End product, I mean that's the end product of the reaction, and there's no going back. Okay, or age. Okay, so that's the acronym: advanced glycation, advanced glycosylation end products. Okay, all right. So, and that's from overnutrition and diabetes. All righty. All right. So, as we go through this, then, and they talk about, this cross-linking and the problems that happen. You get it in DNA, and the DNA falls apart and gets mutated, blah, blah, blah. We have this kind of program view. Is it natural selection? Okay, and so that has stemmed from the observation that genes that make certain animals go into reproductive gasoline rocket fuel, they can go out there and start making new babies. That they put so much effort into that, they don't put enough effort into fixing up their tissue, okay? And things fall apart. So it's this concept of what's good to get you to be reproductive comes back to bite you in the behind later on in life, okay? And so this is concept of antagonistic pleiotropy. So that's true of the insulin and IGF-1. It makes you grow really fast, okay? But down the line, it's going to give you heart disease, cancer, et cetera, et cetera, et cetera. So is this the way we're programmed? I don't know. That's just that theory of what's good for you now could be bad for you later. Our immune systems, okay? They're designed to get rid of nasty ass bacteria, fungi, tapeworms, viruses, and also to get in there and get rid of damaged cells and do wound repair, all right? So that's the good, okay? The bad is when the immune system is chronically activated, you have chronic inflammation, it causes vascular disease. All the people that we watched die over the last 3 years with COVID ended up succumbing to massive lung inflammation. And then what was happening is when you have inflammation, the fluid from your vasculature leaves the blood, goes into the lungs, and basically you were drowning in your own fluids, okay? That wasn't what the immune system was designed for. So it had good intentions, had a bad outcome, okay? Stress hormones, the same way. We're designed with stress hormones to, like, in the acute, I'm going to run as quick as I can to have not get eaten by some timber wolf. I'm out there by the Rockies somewhere. It's all good. And then it was, that little area, I kind of tore up my body a little bit internally with the stress hormone. But I'm not going to be running from timber wolves, 24 hours a day, 7 days a week. All right. So then I can settle down and I can repair my body. Now we can look at the antagonistic pleiotropy of being chronically stressed, psychologically stressed. You're always tearing your body down. So there's lots and lots of examples, okay? P53, all right? This is an example, okay? So P53 is put into place to protect ourselves and go after DNA damage, but it also is a kill switch, okay? That's good if I have cancer. That's bad if we're talking about my brain cells. All right, so there's this kind of antagonistic thing between, believe it or not, people. They've done the study over hundreds of thousands of people, and people who have a ton of P53 that keeps you from getting cancer. Okay, then they. I'm getting this backwards here. If you have a lot of P53, then that's going to keep you from getting cancer, but it also causes a lot of cell death, okay? If you have little P53, you have less cell death, but then you have cancer coming up, okay? Why is that important? Less cell death means less brain cell death. So there's the inverse relationship, okay, between Alzheimer's and cancer. All right, so we can get into the metabolism. You see the mitochondria, that's where we make all of our energy in our cells when we breathe in oxygen and breathe in and take in glucose and burn fats, okay? And so there's this whole concept of energy and how that works, okay? All right, we have to maintain our DNA, all right? If you don't, then too many mutations happen, and then that's when the P53 kill switch taps in. Here's the endocrine part. I already talked about these guys, okay? Linked to nutrition, IGF-1 and insulin. You can look that up right there. These are all the free radicals being okay, and they cause oxidative damage, bam, 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 okay? So that's what this part of this section is. And so you get a lot more oxidative damage if you have a lot more nutrition in IGF-1. But if you fast, then you you can reduce that, okay? All right, so oxidative free radicals can be neutralized by antioxidants. We can do that dietarily, but we can also do things like diet and exercise. So our cells build up a resistance to oxidation. And that's what that's all about right there, okay? So this then clinks into the rate of living theory and linking it to the mitochondria, all right? Lastly, they talk about cell division and the telomeres in this article. All right, guys. So that's what that's all about. So in review, we have a couple of different things down here. These are the key features that are brought up, okay? So every cell that divides, all right, there's a cap on the end of our chromosomes, okay? So you have the cells and they pull apart and you get two new cells, okay? Stem cell and the brand new daughter cell that's gonna go off and maybe have a few more cell divisions and then go do something of function in your body, okay? With each cell division, the telomere gets shorter and shorter and shorter, and that means the next time you ask it to make a new cell, it's slower, and then suddenly it runs out and won't do it anymore. So that's a rate limiting problem, okay? Cancer cells actually nefariously will keep stacking, making the telomeres longer and longer, and they become immortal, okay? Telomere, the longer the telomere, okay, it protects against DNA damage, all right? So as you get older and these things shorten, you get more and more DNA damage, and then that has this cumulative effect of causing errors in the genes, which are the recipes for making new proteins in your body, okay? The proteins become dysfunctional, all right? And now your cells are not going to be able to weather the storm and do their thing, all right? So that's one problem, okay? So some of them will die off. Other ones are just dysfunctional and they accumulate and take up space. So that was the senescent cells, all right? Over on this side, this is the free radical theory, okay? And the big generator of free radicals is our little powerhouse called the mitochondria. And then right here, we have problems in terms of hormones, and we talked about that, the IGF-1, the stress hormone, metabolism, okay, and cell exhaustion, where you're not getting new cells because of what happened here. So these are all these key concepts, all right? What can we do, all right? This is where I'm going to have fun with it a little bit, guys, okay? So maybe we can get to the point that we can use stem cells, all right? That's, there's a bunch of companies out there that are looking into that, okay? I talked about, the antagonistic pleiotropy of inflammation. So maybe we can have more targeted use of anti-inflammatory drugs, okay? Or even things like antioxidant enzymes that reduce antioxidants, okay, like polyphenols and red berries and beta carotene. There's another category I'm just trying to catechins. Anyways, they rejuvenate. Okay, procyanidins and cyanidins. That's what I was trying to think of. Okay, figure out a way to clear out these damaged cells. Okay, and that's a whole area. Can we rejuvenate the telomeres? When we have genes, this is a whole big area where we can turn on and off genes based on lifestyle. So people that exercise and have a good diet, they switch on genes that are good for you. People that have a really crappy diet switch on genes that are bad for you. Can we reverse these switches? All right. I've talked about dietary restriction. There's also intermittent fasting and how it's going to change the activity of different enzymes in your body that are protective. And that's what this is right here, okay? Can we take on strategies that will put out brand new mitochondria? Mitochondria is like your car engine. So it's like having a 2023 Ferrari engine versus a 1992 Volkswagen engine, okay? So you know the difference, okay? So can we put brand new ones in and get rid of the old ones, right? So that's this whole concept that is aging, and the whole goal then is then we're not going to have this horrible. First of all, we'll live longer, but not have such an extended, protracted, progressive, long period of our lives that is just screwed up. Okay, we have tons of disability. You're a couch potato. Maybe you're disabled to the point you can't do anything, but your ticker keeps going forever. Nobody wants that. All right. So what we want to do is extend this out so you can surf forever. Surf forever. For example, let's take a look here. This was Piahi, which is in Maui. the day after the Eddie. All right, it was pumping. All right, so I just want to show you guys this. There you go. So why not do that until you're 70? Well, not this level of surfing, but wouldn't it be cool if you could? All right. Let's watch Billy Kemper. He's at the very end here. I think this is Billy Kemper's right there. Maybe that's Billy Kemper. Billy Kemper is actually married to Bruno Mars' sister. So this guy's probably the best big wave surfer in the world. We saw the bitter end of that. We got to see Billy do this thing. All right, here we go. Here comes Billy Kemper. Is he gonna make it? Oh. All right, why not do that till you're 80? All right, why not? All right, I always figured I'm not going down the pathway of sitting in my chair. If I'm going out that way. All right, guys. So going back to all these strategies, let's look. You guys are business majors. Let's look at some business opportunities that are out there. All righty. So in terms of this concept of dietary restriction and rate of living, there's a key element here. So this is a nutritional supplement company. It is big time. This is just one of many where they're tapping into this concept. So they sell compounds that you would take on a daily basis that are going to mimic what happens when you exercise or when you restrict your calorie intake when you go through intermittent fasting. Okay, the idea, there's this compound called NAD plus that you're trying to elevate in your overall body, in your blood and all your tissue. Okay, and what that NAD plus does, it goes into your nucleus where your DNA is, and it says, can you please set the program for repair right now, because there's no food around, so I got to repair myself. That's what this is all about. All right, so this is a big deal. Okay, you see they've been written up, this and other companies and all these different magazines, and they go into the science. And this is the compound I was talking about, NAD plus, that gets elevated when you fast and when you exercise. All right, there you go. Taking a little bit of science and taking advantage of the world. Okay, that's part one. Okay, what else do we have here? Look at all these theories. Okay, how about this guy? He's been in the news. People magazine. All right, what are we talking about here? All right, so this guy right here. Okay, Brian Johnson. Okay, so he's a big time wealthy entrepreneur. Okay, I didn't know who he is. Who is he? So this guy is a venture capitalist. Okay, I think they said he was 46 years of age. Okay, he was founder of Braintree. Okay, mobile web payment system. Braintree acquired Venmo in 2012. PayPal. Blah 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 blah. So this guy's worth quite a bit of money. All right, so he's killing it. All right, so him and a lot of rich people are throwing all their financial heavyweightness at companies because they want to stay on top of their game forever. Okay, so it's kind of like Dr. Evil. Okay, and so that's what these guys are doing. And so he has this whole treatment program that he's talking about in here, about how he wants to stay young. Okay, he actually has in this article, this People Magazine article. Brian Johnson has a website where he's going through looking at his, remember I said epigenetics? So which genes are are turned on, which ones are turned off, and science allows you to go in there and rate it. So that's what he's doing. He's looking at all these different genes in terms of whether they're optimally turned on and off. Okay, IGF-1, CRP, okay, all this kind of stuff. He also looks at body fat, different readouts. Okay, and how is he doing? So you can follow this on this guy. The idea is he wants to live a long, healthy life forever, like this. Okay, all right. So that's what Brian Johnson has done. What else is there? I would keep my eyes on. So I've gone through Brian Johnson. I've gone through his thing here. I've gone through Asylum. What I would do is I would look at this one right here. This is the next biggie. And guess who's throwing all his weight behind this? So Jeff Bezos of Amazon fame has thrown, I think, something like $100 million at this company. And so they just started. What the first thing to do is they go out there and they hire all these world experts away from academics or wherever, and they put them on this project. So keep your eyes on Altos Labs. They're going to be coming out with products real soon, and it'll be a moneymaker. It is what it is. All right. Very cool. Very cool. Very cool. What's next? All right. So that's the whole. It's biology, but it's business. That's what I'm trying to show you right now, guys. Okay. So now we're going to look at discussions. Okay. So remember the one thing that we were talking about is that we have a limited number of cell divisions, and the best case, not best case, kind of hit right at home example of cell division is the effective aging on female eggs, okay? And those eggs undergo cell division, but also really other cells that support the eggs when you've been impregnated or the egg's been fertilized. So you have these follicles that are all through cell division, and then you have all the cell division that happens in your uterus to form the placenta, and on and on and on and on. Okay, the younger you are, the more capacity. The older you are, the more limited it is. Okay, and then we have cells, okay, on the male side, okay, in your testes that undergo cell division that are responsible for producing both sperm and producing testosterone. As men get older, their sperm number and quality goes down because of the cell division they've gone through their whole lives, okay? Repair goes down because we've lost the caps and you get DNA damage, okay? Told you about that. And your testosterone goes down, okay, which is going to mess with things as well. All right, so when we look at, okay, this concept of telomeres, okay, and we look at it as a function of, well, we're looking at age, okay, all right, so we see here long telomeres, okay, I can protect the DNA in my sperm, I have normal sperm count, and I'm putting, the longer the telomere, the more cell division, the more sperm I can produce, okay, my sperm come out and they're kick-ass, okay, awesome mobile, okay, so we can see it all through here. Beautiful sperm, motility, normal count, good DNA. All right, guys. Guess what happens? You get older. Sorry, okay. And you have DNA fragments. You see this right here. That results in mutations. Okay. It may kill off the sperm, or the sperm that gets through, but not the best quality. Okay. Low sperm count. They're not very mobile in terms of getting in to do their final job. All right. So we can look at the ladies here, okay? We see here long telomere versus short telomere, all right? So when you have a long telomere, the biological age of your eggs, of your body is nice and young, all right? You can have multiple births, all right? So you have lots of capacity, all right? Your estrogen levels are high, which helps drive your uterus so you make beautiful eggs, okay? So you have a greater likelihood of getting pregnant. Your estrogen levels are high, so you're more likely to produce lots of milk from when the baby comes, okay? What happens is you are also very clear of cancer in your ovaries. You're looking good, okay? So what happens when you get older and your telomeres get shorter, okay? Then we have a problem, okay? So we see you go through menopause, all right? You have before menopause, you're more likely to have miscarriages. You don't have very many eggs you're pushing through the system, so you're less likely to get pregnant, okay? Problems with the maturation of your eggs, and we see this dramatic decrease in telomeres. So that's kind of what you're up against, all right? So what we want you to do, given this background, is I want you to think about it right in here, okay? About your reproductive future, okay? And this balancing act you guys are doing between getting yourselves ready financially, because that's what it's all. I mean, you're going to school to get a job, and now we've dramatically extended that time it takes to get skilled. So suddenly, we already saw that there's a good chance you're not going to get married. But let's say you find somebody you want to have a kid, you're late in life, and that was kind of me. I met my wife when I was almost 27. We didn't have our first child till I was 39. Okay, all right. So my sperm was kind of suspect, and then And then we had lots of trouble for number two. All right. So in fact, we actually went this route. You see right here. So yeah. So these are what your choices you guys are gonna have to make. So so I want you to look into this. So this is a great website where you educate yourself. So you go into this website right here. It is a POMA fertility website, okay? And it talks about your fertility, right? So you can see here that you've gone to college, now you go in, got your MBA, you got your job, okay? Now you say, I'm ready, and look what's happening. Your fertility is going, okay? Um, that's for women. We're going to see that men, we carry equal load, okay? So, how are you going to determine your fertility potential? Okay, we can look at your egg quality, okay? And the concept of the egg quality is we need to see whether or not we can stimulate enough eggs to go through here, and how many do you have, all right? So there's all these different procedures that we're going to look at, okay? We're going to count the number of eggs in your ovaries. That's what the AFC is. We're going to look at a hormone, okay? The AMH hormone right here that that limits how many eggs go through per cycle, okay? And believe it or not, it's good to kind of limit things because that way you'll have more eggs later on. And then the other thing is when we hit it with the gasoline, which is this follicle stimulating hormone, how likely do you have eggs come out and have the follicle rupture and have yourself ready to rock to get pregnant? That's what that's all about. So we can look at FSH, okay? And so this is, if I go back here, I want to go back to this figure right here. So what happens is we cycle where your eggs produce estrogen, and finally your brain sits there. So this is your brain, this is your pituitary. The brain is sampling the estrogen. When it finally gets to a super high level, boom, it puts out what's called follicle stimulating hormone. And then that causes this follicle, which is the egg, to rupture, and the egg then goes down to your uterus. And if you're lucky, you get pregnant, all right? All righty, so let's look at women and a function of FSH, okay? And how many live births happen, all right? So this is just across the board. We're looking at women that are 35 and younger, 35 to 37, 38 to 40, 41 to 42, and 43 and older. Awesome, okay? And then we're looking across the board here at the cutoff value in terms of SSH and the delivery rate, okay? So we're looking at how much FSH needed to be produced to produce a baby. And we see over here that the younger you are, the more likely to have a successful delivery, okay? Over here, where your body needs more and more of FSH, it's less responsive, you got a problem, okay? Alrighty, so that's what that's all about right there. So we'll look at your FSH levels, okay? More information on SH. We'll also look at the clomiphene challenge test. I'm going to explain what that is in a second. And then we're going to measure this hormone that limits how many eggs come out of you, and that's the AMH, okay? Lastly, we can do this count, where it's basically an ultrasound. We're going to count the number of eggs you have. So this is the whole readout that a fertility doctor would do. Well, by the way, that's how much it's going to cost you to do in vitro fertilization. All right, so and not all insurance companies will cover this. So it's kind of a big deal. All right, okay. So let's go back here. So I'm going to get out of there. All right, and we're going to go back to this. This is all something for you to think about. All right, good time to educate yourself, ladies. Okay, so this is this clomiphene challenge. Okay, so what happens is your brain right here. This is the base of your brain. This is your pituitary gland that is kind of like the air traffic controller between the body and the brain. So the brain samples information. In this case, it's sampling the estrogen that is released by your ovaries. More estrogen is released as the follicle gets bigger and bigger. That's the way it works. These guys that surround your egg are the guys that are releasing estrogen. More of those cells, more estrogen. So what happens is as you're slowly increasing estrogen, all right, you're going to increase this hormone that tells FSH to get bigger and bigger and bigger. More follicle stimulating hormone, you're going to stimulate the follicles until this guy goes out and ruptures, okay? So I can make you a super ovulator, my friends, all right, by basically injecting you with a bunch of FSH. Okay, that's point one. The other way is, so what happens is this FSH is stimulating the follicles to move, and then this second one, LH, what's called luteinizing hormone, gets released, and then that causes the rupture. All right. So if you give this drug, clomiphene citrate, then the brain sees kind of an intermediate level of estrogen for a long time. All right. So your cycle would really extend outward. When you have LH, either you get pregnant or you go through menstruation. Okay. So you don't go through menstruation, and what happens is you keep the FSH is there without the LH, and you push out, instead of one, you might push out 15 eggs. Okay. Um, and then you stop, you come up with a placebo pill, LH gets surged, instead of one rupture, you may get 15 rupture, or something like that. And this is how people have quadruplets. Remember the Octomom, this is all how that happened, all right? So that's how clomiphene works, all right? Here's more drugs right there. Sometimes that's not enough, because then you grow up the fetus, okay? The little 8-cell stage, and then you put it into the mother's uterus. Okay, so this is in vitro fertilization. All right, so you start with egg and sperm. You get fertilized eggs. You maybe get 10 or 12 of these in a petri dish. Okay, you can sample them, make sure that because they start undergoing cell division. You can take one cell off and make sure it doesn't have any chromosomal damage. And then you take the growing little embryos, okay, and you put them into the mother's uterus, and then they become the fetus, okay. That's in vitro fertilization. Remember, that's 15,000 maybe. Over here, this is a pretty cool readout of some of the problems that happens with sperm age. Okay, so we see right here, these are different effects. We're looking statistically, okay, looking at baseline, and then you make some adjustments, statistical, and so this right here is the statistical adjustment. And what you see here is, as a function of daddy's sperm age, the likelihood of autism goes up. Okay, so this is where you would have, you sample thousands of people with fathers that are maybe over 40. Okay, we see the father's ages here. Okay, but you keep maybe the mother's age constant. So the only variable is dad's age right here. And you see the likelihood of ADHD is huge as a function of dad's age. Psychosis, bipolar disorder, likelihood of suicide, substance abuse, okay, poor performance in school, blah, 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 blah. All right, guys. So what we want you now is to think about this conflict that you're having right now with yourself. How long do I pursue education? Do I even want to have children? Why do I have to make these choices? That kind of stuff. All right, guys? Okay, so that's it for today's lecture. Peace. Contact me or Julia for having any issues. My phone number is 949-292-5198. Julia's is 949-292-5199. You can text us. You should email us. Don't let things get out of hand, okay? You keep us in the loop. All right, guys, take care, and we'll see you next time.